Hi everyone, my name is Dhruv Sharma and in today's session we're going to cover about Cisco Nexus. As we have discussed earlier, we're going to take our every topic from zero to hero approach where we will be discussing every topic from ground zero level and we will try to educate our viewers to an expert level. So on that note, let's jump in. So Cisco is already for a very long time they are in the data center environment and they are producing lots of switches. So it's it's not nothing new, but yes, they are basically uh, are the biggest manufacturer of the switches, and it's not the first switch, the Nexus they have produced earlier. They have Cisco Catalyst switches, which they were producing and which was quite popular. So one of the big question everyone comes into everyone's mind who are new to this environment, where what's the difference between a catalyst switch or a Nexus switch? Basically, catalyst switches are still in use, but is basically catalyst switches are basically a design for distribution or core layer within the campus network environment. But Nexus switches are used for data center deployment. So so in a nutshell, Nexus switches can support Ethernet and fiber channels or FCOE, but Catalyst switches are pretty much focused on Ethernet. So the Nexus switches have some cool features like high availability, high performance. It has scalability and operational continuity. So in a nutshell, we have these variants of Nexus available in the market. So it starts with Nexus 1K, 2K, 3K, and is moving in this direction where we have Nexus 7K, and finally the Nexus 9K, which is growing and moving around Cisco ACI. So I will not be covering Cisco ACI in this video, but yes, we're going to take it up from zero to hero level in our upcoming video. So that's definitely on my agenda. All right, so we move forward. So yeah, so Nexus 7K, we're going to start with Nexus 7K, which is right now used by various customers. So what are the building blocks or the main components of this Nexus 7000? When we say Nexus 7K, so these are the variants which are currently available. These are the pictures you can see. This is how the devices physically look like. And these are the main components. So it's chassis, input-output modules, SOUP, what we call a SOUP, it's the full form is supervisor engines, and the fabric modules. So chassis is nothing but the physical components. It consists of fans, power supplies. So it's basically the physical chassis of the device. And second component is input and output modules like MNF series cards. It's pretty important. We're going to cover it up in next couple of slides. So these are the series of line cards which are basically pushed into the devices, and that's basically from where the patching of the cables happen. So there are two type of series of cards Nexus switches supports, that is MNF. And the supervisor engine, that's the brain of Cisco Nexus, which basically perform the control plane. So, so input output modules is basically data plane, and supervisor engine basically perform control plane. It has redundancy option because if the supervisor engine fails, so it can fall back to its backup. So every chassis except Nexus 7702, uh, it doesn't have a backup for the supervisor, but rest of the chassis they have backup for the supervisor, and it's very important to have that backup for your supervisor because it's the brain of the switch. Yeah, and the management port basically belongs to the soup. Yeah. And finally, the fabric modules. That's a fourth important component, which basically we're going to discuss it in this slide. It's one of the best topics you guys can get in an interview. So yes, we're going to cover this up. All right, so we can proceed. So Nexus 7K basically, it classic Cisco Catalyst switches. You guys must be aware of iOS, right? So you're going to have Cisco iOS which are installed on them, but Cisco Nexus, they don't use iOS. We call them as NXOS. So NXOS images are installed on these appliances. We're going to look into about the OS and operating systems in a couple of slides from here. But yes, you must be aware that the operating system is not iOS on Nexus switches. It's NXOS. And similarly, if you guys are aware of Cisco FTDs, they don't use neither NXOS and iOS. They use iOS XE. So you can see over here. So these are the type of OS Cisco FTDs and all supports. So Cisco has basically divided their operating system based on the kind of hardware, kind of the devices you are trying to use. So that's pretty the difference. You can see we can see that supervisor modules and lots of you can see the slots. It's pretty easy. Guys can, I will not going to take some time into it, but you can see what is the difference between these series of switches, and you can basically go through it. And if you have plans to purchase a device in your offices, so this is a good comparison sheet. Yeah, that's pretty important part. I would like to bring it up because this took many guys in around, they were really literally confused, like what's the difference between MNF line card, and it is very important because you have to pick the right or you have to order Cisco the right line card which suits your purpose. So Cisco initially introduced F-series interfaces, which this was the first type of interface that Cisco introduced was layer 2. So it only had layer 2 functionality. So an M-series Cisco introduced was provide function of both layer 2 and layer 3. I reckon M-series interfaces are a bit more expensive, but yes, F-series are layer 2 interfaces only. But yes, as time proceeds and as per the the requirements of the customers, so Cisco had various other variants of line cards. So they came up with F1 series. So that was the initial version where they have only L2. F2 series that has layer 2 functionality, but basic of L3. It didn't have you can just do basic SCVI kind of concept. And later they also came up with F2E, which is similar to F2 and F2E. They fundamentally F2 and F2E are same, but the performance of F2E is much better, so more capable. So interfaces of F2E, their performance is much better than F2. And finally, they came up with F3. So F3 is an advanced. It has some advanced features which I have shown over here. You guys can review it. M1 and M2 is layer 2 and layer 3. So again, M2, the functionality is same, but M2 has some higher performance. So if you have to purchase the right kind of interface based on a requirement, if a backup server, if it's just a layer 2, or so I can go for an F1, or I can go for an F2. So costing plays a very vital role for the type of interface we're going to opt for. So I'm not going to take much time over the chassis comparison. It's there on the slides. You guys can definitely revert back to it and see it. Yeah, so that's where basically I'm coming from. The main objective of this video, I'm trying to explain the differences between the Catalyst switch and what's the new feature Nexus switches bring on the table. So Nexus basically, interfaces on Nexus are basically all, from the interface perspective, all the Nexus switches are 10G. So I didn't all the interfaces of Nexus switches are 10G, but if you log in on the CLI, you will see it's all displayed as Ethernet interfaces. So you should not get confused from your first look that these are 1 gig interfaces, but these are 10 gig interfaces, and the slot number doesn't start from 0. So you have to be very conscious when you design your solution. So that's one of the difference which I have personally noticed. The second difference, we're going to discuss all these differences in very much detail in our upcoming slide. The licenses. So licenses, unlike Cisco Catalyst switches, the licenses are, you know, if you go on a Catalyst switch, you just have to power it on and do the patching, and you're ready to go. But unlike these, on Nexus switches, it needs to be you need to install some licenses, like any firewall. If you want to use some features, you need to install the licenses, and once you install the licenses, you have to enable these features. So if you go here, you have to enable these features. Unless you will not enable those features, you can't use them. And using a command, you can even see that what all features are currently enabled on your switch and what are not. Yeah, and a concept of user roles are introduced. So you can roles and and users are assigned to a role. So this kind of functionality is also introduced on Nexus. And yeah, unlike Catalyst switches, you have seen on a previous slide where I explained that and Catalyst switches you used to use iOS, but Nexus comes up with NXOS. It's not a single image. If you try to, if someone asks you that how many can I just upgrade a Nexus switch using a single image, but the answer is no, because NXOS or a switch which is running NXOS is on a background is running in 3 sub images. We're going to look into it in just a couple of minutes from here. And the other function, write command, doesn't work, so you need to issue a copy run start command. Yeah, that's a very important point you have to remember. Okay, we don't use macros like Catalyst switches, we use port profiling. So we're going to look into port profiling as well, where if you guys are aware of it, we can push configuration to multiple switches by creating a profile. So for major deployments, this stuff comes very handy. The new feature FEX fabric extenders. It's a new feature which is available with Nexus, and we're going to look into it as well. Supports VDC, and it supports, so virtualization is introduced with Nexus, and it has been taken ahead with ACI. So, but yes, the foundations are laid within Nexus, where it supports VDC and VPC, and it also have VRF. So it's a virtual routing forwarding engine. It's a multiple routing instance you can create, and VDC is something where we can create virtual. We can have some partitions where a single router can act as a 2 different routers, and it's a VPC is a port channel. We're going to look into it in great details so that everyone can basically understand what we're talking about. And Nexus also supports FabricPath. We're going to look into it. As I mentioned, it has from first face, it looks like that it's Ethernet ETH, but we are not supposed to be confused that these are 1 gig interface. But yes, these are all 10G interfaces. You can using this command, you can basically look into it. Licenses. As I showed it to you, you can enable a grace period license using this command, and not but I reckon if we enable this grace period licenses, you can't still create multiple VDCs. Yeah. Okay, so unlike, as I think we have discussed it already, you don't you need to install some licenses and enable it in the feature section. If, for example, SSH is enabled by default, but if you need to use Telnet, you have to enable this feature. So show feature command basically can show you what all features are currently enabled and what are disabled. So you have to enable it manually. As I discussed, user accounts. User accounts, we have these user roles. So if you have a big enterprise and you have a large set of users, you can just create user roles and you can assign those users to the user roles. Nice and easy. So based on the user profiles or user attributes, you can assign them to it. But yes, still Cisco is carrying their functionality where they still have a concept of privileges. So if you have a privilege 15, you still have the highest privilege, but it still has a concept of user roles. I've shown it in from, I've taken a screenshot from my router. So how you can create a user and you assign it to a user role. Nice and easy. NXOS, yeah, so that's the interesting part. Where NXOS basically, unlike Cisco router or Cisco ASA or any firewall, its OS basically consists of 3 images. So you actually have to install 3 images to get a Cisco Nexus switch up and running. So first is the kickstart image, where it basically has its drivers and kernels. We don't usually upgrade these kernels in Cisco Kickstart image on a regular basis, because unless Cisco highly suggests it to you, because there are existing bugs trying to fix. There is a system image where the operating system is trying. Basically, this is the one which we basically try to upgrade when we're trying to go on a higher version. And the third image is basically EPLD, which is electronic programmable logic device, which is an image to upgrade or enhance the hardware functionality of the interfaces, I would say. So if the interfaces of a Cisco Nexus is acting funny, you have to go back to Cisco and ask them, and they can ask you to upgrade your EPLD image. Yeah, you can, from show version, you can get details of all this OS which are currently running. Spanning tree, yes, Cisco Nexus supports, they don't support the legacy STP protocol, but it do supports RSTP protocol. In addition to it, it also supports MST. You can get those details from your end using these commands. I've pasted some screenshots. I'm not going to go into details because it's all available on internet and on existing YouTube videos. That's how you basically increase the priority. Yeah, support profiling, unlike Cisco iOS, where we use macros. Using these commands, basically you can do the same kind of stuff what you used to do for iOS, where we can create a port profile and do these stuffs. So these are the commands and the CLI configuration, and you can refer to this link which is there in the slides, where you can get you can demo configuration how to create those configuration. Yeah. VDCs, that's pretty interesting topic, where VDC is where we have the virtual instance of our router currently running. So Cisco come up with virtualization of after Cisco Catalyst switches, where we can create VLANs at layer 2. So that's a virtually we divide interfaces. So that's at layer 2. At layer 2, VLANs play a vital role for virtually dividing the LANs. And at layer 3, they have a VRF, so virtual router forwarding, where multiple route is I think it's nothing new. Juniper SRX and lots of vendors have the VRF concept, where multiple routing instances are running on a single switch. But in VDC, we have, so in a VRF, so this is a single router, but 2 routing instances. So Ethernet 1, Ethernet 2, routing instance 1, routing instance 2, 3, and 4. So in VRF, so there are two routing instances, and Ethernet 1 and 2 are part of routing instance 1, and Ethernet interface 3 and 4 are part of routing instance 2. So they are practically still a single switch, but they are multiple routing instance, and using some stuff we can transfer some routes from this domain to this domain as well. But yes, still there are two routing instances which are currently we can create multiple routing instance. So that's still a physical one switch, but using virtualization where we can create a single router can have image of or a virtual instance of running multiple multiple routers, and for the end users they will basically believe that it's a multiple routers they are connecting to, but on a physical level there are still a one single router. The physically they are still a one single router. It's a very cool technology, yeah, and it's been used everywhere. So number of VDCs. So the question comes like how many VDCs we can create is basically depends on the supervisor module, and you need in a nutshell, SOUP 1 supports 4 VDC and SOUP 2 supports 5 VDCs. Okay, so managing, this is pretty important where we can have multiple VDCs, VDC 2, 3, and 4, and the supervisor. And yeah, so the default VDC is used for the management purpose, and we can from the default VDC, you can basically switch into its child VDCs. Yeah, so the default VDC is used to switch into the child VDCs, and from the child VDCs you cannot directly go into the other child VDCs. So you need to go through your parent to switch into their child VDCs. So that's one single rule, and you can either have a one single management IP address and you can switch it to multiple VDCs, or you can assign multiple management IP addresses. So the configuration is pretty simple, honestly. So the configuration over here, I've placed some screenshots and I've provided them commands as well. You know, commands are available on all the Cisco documents. You know, the best part about Cisco is they have such a rich document database, so we don't really have to worry about of the commands exactly. But yes, go to config terminal, create name myVDC, and allocate the interfaces, and that's it. You're good to go. You have to switch back into the VDC, and you have to this will act as if you are into the real-time switch itself. Yeah, you can just quick note. You can view update licenses only from the default VDCs. So that's key point. You can't upgrade or update a license from the into the child VDC from the child VDC itself. You know, what I mean, you have a main switch, and these are the child VDCs. So if I want to 1 and 2, if I want to upgrade this child, you can't upgrade it directly from the child itself. You have to upgrade the parent VDC, and automatically the child will be upgraded. And the licenses, you can't just update a license for a child VDC from the child, from logging within the child VDC. You have to come out into the parent VDC. High availability. So yeah, what happens if a VDC in a switch is corrupted and it's not operational? So you can basically configure a command under the VDC where they had a policy to, to, to notify whether you have to bring down a VDC or reload a supervisor, and or you can just restart the VDC itself. So as soon as a VDC have a problem, it can bring down the VDC completely, so decommission it, and you have to reconfigure it, or you just reload it. So I usually have seen in the production environment where we either choose this option or choose this option. So I've seen most of the time I've seen the third option. That's why we said it's most desirable, where it just restart the VDC. reloading the supervisor is not really a good option because a switch might be running multiple VDCs, and restarting the primary supervisor might impact or will impact the other VDCs as well. So this option you should always choose in your environment. That's FEX perfect, and I really like this FEX extenders because it's the demand of the current industry where the interfaces in a switch, Nexus 7 gate, these are very expensive switches and expensive ports, and likely, it's very likely the interfaces are occupied and you don't have enough interfaces are left on Nexus 7K. So the easy way out, enterprise can basically buy a FEX extender. So one interface can attach to a FEX extender, and the FEX extender can have multiple interfaces available to it, and you can attach your servers directly to these FEX extenders. So in this way, on a physical switch, the primary chassis, you are still using a one single interface, but on the FEX, you still have multiple interfaces available. But note, this is just an extender, so it will not going to run some protocols like STP, or it will not going to have some BPDU guards. All sorts of stuffs are not running. All the switching decisions are still taken care at 7K level. So that's a Nexus 7K. That's a parent device, and FEX extender is over here. That's it's a 2K Nexus 2K, and it's connected to the parent device, and all the details and all the traffic flow, if this guy wants to communicate to any device, so all the traffic will first reach to this interface, and then finally it can go back and reach to can communicate to other guy. This Nexus 2K appliance will not going to take any decision. So this is the configuration. Typical configuration we're going to use a Nexus 7K and 5K. You guys can refer to it. I'm not going to take much time into it because the configuration is pretty simple. You have to create a FEX, enable this feature, install the licenses, maximum links to, because there are two interfaces, 2 points, and I think that's is quite self-explanatory. I'm not picking up this port channel stuff right now because I'm going to take it up in a separate section in upcoming slides. So this can show that once you're going to upgrade it, once we have this image installed on the parent, this image will be downloaded on the child, on the FEX devices. So you can see the state is image downloaded, and finally the image will be online once the device is ready to use. VPCs, that's pretty interesting topic. I think as I mentioned, I'm going to pick it up VPC in our coming up slides. It's one of the important section, and in interviews you will if you're appearing for a networking round, so networking interview, this question is likely to be asked when what's VPC is all about. So VPC is basically aggregation. It's nothing new. It's Ether channels is available. This feature was available in our old switches, and port channel is available with Nexus switches, which is nothing but aggregation or bonding the interface together. So you have one single switch, but to provide it can directly connect to a server. But what happens if this switch fails? So we can have an additional interface which are connected and aggregated as a port channel. So this symbol like circle basically identifies that in a network diagram, that identifies that we are configuring port channel. So why? So the key benefits of why we use VPC. So it comes up with 3 important benefits. So increased bandwidth, avoid STP, and redundancy. So what we mean by increased bandwidth, that once we have multiple interfaces in a bundle, traffic is load balanced across multiple interfaces. So if I have two interfaces, so I can configure, typical topology can be, this is, sorry for my bad drawing, this, so this guy, 1, 2, and 3. So one guy is trying to send the traffic to a destination, so it can send one session through switch 2 and another session through switch 3. So it is load balancing the traffic. It suppose various load balancing protocols. I would say not load balancing, but it suppose LACP and PAGP as a protocol when we're going to configure it. These are certain facts. Only layer 2 links are used with VPC. Routing protocols will not be configured. You can't have a layer 3 functionality once we're going to configure a VPC. So purchasing M series interface for, if you have if just need to ensure that if you want to configure a VPC, just not order an M series interface, because M series interface has a layer 3 functionality. I would go for F1 series because it just to provide layer 2 functionality. Yeah, why we use VPC? As I mentioned, it provides it basically deletes, it doesn't eliminate the use of HTTP, because port channel, when we have two interfaces connecting together, as I mentioned over here, it basically, HTTP is not eliminated. But if you ask anyone the port channel, like why we use port channel, a typical answer is that we don't need HTTP. HTTP still runs on the switch. It's the mandatory protocol, and it still runs through the switches. But still, since the two interfaces, they are binded together. So how can I explain you? Basically, there are two switches. If they are currently connected together, so because of HTTP protocol, it will going to block certain protocols, certain ports, right? It's going to have it will make this port as blocking in nature, this as forwarding. So between switch 1 and switch 2, one port is in blocking nature and other port is in forwarding nature. So with using HTTP, we are basically not using the interfaces in a very we're not using it at maximum capacity, because HTTP, its very nature, we're going to block the ports. So the best way I would highly recommend to you to go for VPCs, because in that way we are basically using the switches with its maximum utility. We can take the maximum advantage of the switches. That's why we recommend to go for VPCs, and that's, as I mentioned, always remember that HTTP is not, we're not removing HTTP from the switch, but yes, it's still there, but it's not as much used, because two links are acting as a one. So if I will show you here, yeah, okay, I have a picture for you to basically show you how it looks like. Yeah, so these are switch 1 and these are switch 2. If you run VPC, this is how switch 1 and switch 2 will going to look like. So physically, these are switch 1 and switch 2. They are physically different switches. But yes, when we look into it, this is how the logical view of this topology. So the deployment in VPC can happen in two ways, double-sided and single-sided. This is, which I discussed, where the packet can be load balanced in link 1 and link 2. And over here, this is the second single-sided topology. So double-sided topology, which is shown over here, and single-sided topology. So VPC, a couple of important points I would like to pick it up, like which is really not available on, which I found it not really available on internet. So I'm going to pick up a couple of points where VPC use a unique MAC address. It doesn't, when these switches over here, if you see, once they are part of a VPC, they will create a new MAC address using this as a prefix. This will remain same, but it will end with the VPC domain ID in hexadecimal. You're going to look into it. and what's domain ID is all about, but that's the key point. Yep. And it's very important to this, because MAC address plays a key role to understand why I bring this topic in advance, so that everyone can understand it. Because this VPC MAC address, this MAC address plays a very vital role. You have to remember this prefix plus domain ID. I will explain you why it is so important. Okay, so VPC has two roles. So it has a primary and the secondary switch. The two switches, I can go back. It can be primary, it's secondary. Don't confuse it as an active and standby. So it's not active and standby, it's primary and secondary based on the responsibility of control plane. It's control plane where the primary will going to process the BPDUs and ARP request. And the secondary, the traffic is managed by both of the switches. So the both switches will going to manage the traffic. It just the primary switch will going to basically perform these two functions. The rest of you can go through the slides. I'm not going to invest much time. Okay, the configuration is just complete in four simple steps. It's pretty simple to configure it. The VPC domain. The domain basically explains you that what two VPCs, the peer devices, are part of the domain. So yes, these two, it identifies whether the two devices who are in part of a VP, they are part of a VPC. I say, so it identifies these two switches. They are acting as a one switch, and that is identified with the domain ID. You're going to see the configuration. So this domain is the first step. You have to assign, create a new domain, and create. The second step is to create VPC Keep Alive. So this is very important. The Keep Alive ensures its health checkup, and to ensure that there is no split brain. It's a very important question for interviews, where how to avoid split brain, where it doesn't understand, the control plane, how to understand that if the traffic is being load balanced currently. So 1, 2, and 3. Okay, and this is the destination server. Let's assume. So this source server is trying to send traffic to the destination from 1, 2, and the third hop is the destination server. What if this server goes down? So the health monitor will going to inform that not to send this traffic through this link. You can send the traffic through this link and finally to the destination. So the Keep Alive is a health monitor to ensure to inform that and will inform the VPC links that further communication will not going to happen on this interface through the faulty switch. The third step is to configure peer link. Peer link is nothing but it's used to synchronize the configuration. Both switches are independent. They are physically different switches, but they're acting as a one switch. That magic, the magic of creating a logical interpretation of a two physical switch happens at this peer link. It used to synchronize the data of control plane. That's pretty important, and it creates a logical entry of how two switch are acting as a one is basically taken care by a VPC peer link. It happens to be a layer 2 interface, and please ensure that Keep Alive is always a layer 3 interface, and it works on UDP 3200. And finally, the member port assignment is the last step, the fourth step, where you basically on the switch identifies which ports are basically needs to be part of the port channel. We're going to look into the implementation now. And just to ensure, these Keep Lives have a default timers as well. You can use the default timers. In my organizations or previous experience, we have using the default timers, but you can definitely increase it by obviously consulting Cisco. That's the topology in the lab. So we first, as I have always mentioned, we have to enable the feature, create a domain, switch A and switch B. So the domain needs to be created between these two guys. And one, you have to create it for keep alive. The second step was keep alive, if you remember. It's a layer 3 interface and work on port number 3200. It's a layer 3 interface. I assign an IP address. It's an option. We can create a VLAN and add that VLAN attach it to the interface and create a VPC domain. And this is the magic command where we need to identify, we need to mention that this is my source IP .1 and that's the destination IP. And likewise, you have to do configuration on your second switch as well, switch B. And the switch B to set up the peer link. So peer link are these two links. A separate link needs to be created, for one for the keep alive and other for the peer link, where it is highly advised to create a port channel on it. We enable the feature LACP so that the traffic can be load balanced between these two links, link 1 and link 2. Sorry, yeah. And we create a port channel 1 and interface port channel. We enable and trunk all the traffic. We can either trunk, or you can identify that only VLAN 300 needs to be trunked, and VPC peer link and interface 1/20. You can have one interface or you can have multiple interface. The Cisco highly recommends to create a peer link using a port channel. In my case, I've created it without using a port channel, but you can definitely create it. And that's the configuration you need to do at your end. And finally, last but not the least, you have to create and match those interfaces. So the configuration is mentioned it over here. I'm not going to explain it in much detail. In my case, we are using the port number ETH1/1 as a member port on the switch. Similarly, on the port switch B, I'm using ETH2/7. That's the configuration. Configuration is pretty simple. You have to create a port channel 10. As soon as you're going to do it, you will paste this command. You can go into the port channel 10, interface port channel 10, and do the rest of the stuff. I would highly recommend that you create a VPC, VPC 10, same as port channel 10, because to avoid any confusion. So the numbers should be same. Otherwise, if you give up port channel number 20 and over here is 30, while you guys troubleshoot the issue, it will be very difficult to understand. So VPC command and the port channel on real-time basis, I've seen the number should be the same. And the configuration will follow for this different topology. That's the double-sided. And you guys can refer using these commands that the keep alives are working. It's pretty easy. You can go through all these details which I've pasted. It's the configuration are pretty simple, honestly. The Cisco, their commands and all, it's all mentioned on the link. You guys can refer to this PPT, and you can get all the details. Question and answers. Yes, pretty important. I was posted these questions from most of my colleagues and my friends. I've taken these up. While managing the VDC, it's difficult to identify whether you are at an admin or you are at the child VDC. So this command, VDC combined host name, will basically help you to understand whether you are currently in a child VDC or you are at a parent VDC. Question number 2, Nexus 2K. If Nexus 2K, I think this is for FEX link. If FEX link is broken, will Nexus 2K will retain the configuration? Answer is yes. So if you like the FEX extender, if you remember, we show you one interface. You can have a FEX extender that can have a multiple links. What happen if the FEX link is broken? Yes, the configuration is still retained by this guy. Yeah. Any DR functionality with Nexus 2K? What if the cable between Nexus 7K and 2K is disconnected? So, the FEX extender, is just a one single cable. What if this cable is disconnected? So, it's highly recommended to use FEX pinning redistribute command or configure it as a port channel so that you have an extra cable, because what if this cable is disconnected? All the connectivity for this guy will be lost, right? It's better to connect an extra interface and connect to this guy so that if this guy fails, you still have the connectivity. A good question. Any recommendations for keep alive for VPC? Yes, there is a recommendation where it is not really recommended to create a keep alive over the management interface, because you know management interface is, if you create a VDC on a single switch, right, and you're going to create VPC on the same switch itself, what I mean that since VDC, they're acting, one single switch is acting as a multiple switches, and you can create a VPC ETH 1 and ETH 2. So VDCs are, as I mentioned, they are physically one, but virtually they are multiple. They're acting as a multiple switches. So practically, yes, you can create VPC between these two switches, but it is not really highly recommended to create an interface on a single between two VDCs running on a same switch, and it's also not recommended by Cisco to create a keep alive. If you are really configuring it, if you want to save any cost, practically you can, but it is to use a keep alive. It is highly not recommended to use a management interface in such scenario. Yep, to send the keep alive. Yet I think that's pretty common for all the devices, even for Cisco ASA. They don't recommend to create keep alive traffic by directly connecting the cables. It's better to connect through a switch, because if one switch fails, you still have, it's help you to troubleshoot the issue, and 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 the second importance is that every switch has, usually, except most of the switches have backup of soup engine, right? The soup, they have primary soup and secondary soup interface, which are basically connected, and if this cable goes faulty, so there is no way this guy can reach out to soup too. So that's why it is highly recommended to keep to attach the cables using a layer 2 switch. Any recommendations for setting up a VPC? Yes, I think I have already discussed that it is not really recommended to create a VPC between the same switch, but yes, you can create a VPC between the two switches. What are orphan devices? If the devices which are still connected to Nexus switches, which are not part of a VPC, they are known as orphan devices. I'm just trying to get you guys familiar to these terms. Maybe you can get these terms in an interview, or maybe while you're working or going on a call with your customer, or in your IT calls. What are orphan ports? These are ports which connects to an orphan device. What if a VPC peer link goes down? VPC peer link goes down. This peer link goes down, but the keep alive is working. So if VPC peer link is not, I'm not talking about keep alive. If VPC peer link goes down, the keep alive will going to inform. We're going to inform let's say we're going to inform the primary switch that the secondary switch interfaces are down, and primary VPC without an will be continue to take all the traffic, and all the services on the secondary VPC will be suspended, and all the traffic which was initially handled by the secondary switch will be forwarded to the primary switch. Pretty simple. Okay, Cisco Fabric services. Yeah, so I think Cisco Fabric Services Protocol. I think I'm going to discuss Cisco CFS in bit of a detail, I guess. Yeah. Okay, fine. Cisco Fabric. So what is Cisco Fabric Service? So I think it's a very small topic. Let's me pick it up. It's basically used to provide reliable synchronization and consistency mechanism between two peer device over VPC. So it's a very popular question. You know, you get in interviews. You know, it's a what protocol basically work. If I show you, okay, yeah. Let me get you explain you in a diagram. Yeah. So this is a peer link. So to synchronize, as we know, this VPC peer link is used to synchronize the configuration or the control plane between a primary and a secondary nexus. But what work in the background? The background, this protocol, the CFS creates all the magic. So basically, CFS is the main guy who basically syncs all the traffic, and it performs all these 5 functions. I mentioned most of the details in the slides. You guys can basically refer it out once you go through the slides. Okay, the setup. These are some, I've pasted some configuration just for references. You can basically go and check it up. This comes pretty handy when you go on a live configuration. A couple of few points. Yes, you can configure rollback of configuration. You do any changes on the device, you can roll it back. TCP dumps, yes, you can take a TCP dump for control plane. You can use these commands. And TCP dump in the data plane. Yeah, FabricPath. Quick checkup, quick walkthrough of this topic. It's pretty important. I have not really seen it used in most of the deployments, honestly. But yes, it's one of the top topics I've seen it, you know, on the interviews where where someone was like, it's a popular question that routing does it in which layer in the OSI model basically routing happens. It's a very simple question, on in the interview, and everyone answers it that it's happened at the layer 3, the network layer. But with FabricPath, the routing also happens at layer 2 using a routing protocol ISIS. So not with OSPF, not with BGP, but with ISIS only. Why FabricPath was introduced? To remove the dependency on STP. So it removes STP and it VPC, so VPC only on 2 switches, and it supports full mesh, partial mesh, and triangle square, all kind of mesh it supports. So it has a layer 2 MAC routing. That's typically how we call it, and you can use it FabricPath as L2 routing. So with FabricPath, layer 2 supports routing using ISIS and STP. So if you're not really very familiar how ISIS protocol work, you don't need to really worry about it. The configuration is very, very simple. So what really basically happened. Let me show it to you in this topology. We create a FabricPath core cloud. So that's you have a access switches, and maybe this can be a catalyst signal. Sorry. One moment. Okay, so in your enterprise, you have 3 Nexus switches, and this switch and this is a host A, and this is a host B. This host A and host B wants to communicate through each other, and they don't want to use STP because honestly, STP is such a waste of ports, because most of the ports are in blocking, and to avoid loops. To avoid layer 2 loops, you have to be in blocking mode. So to avoid that stuff, we can create a FabricPath cloud where the where we can avoid routing loops or broadcast storms at layer 2 level using FabricPath. What happens, an extra frame is basically added along with the layer 2 headers. What happens, we're going to show it to you. Server A is trying to connect to server B, source MAC, destination MAC, and the payload. It reaches to the edge device. This is the but as soon as it hits the point number 3, an extra header, which is the source switch ID and the destination switch ID, which is 11 and 10. So the source switch ID is 11 and the destination switch ID is 10, is added as an extra header on the payload. It reaches, and as soon as the payload reaches the edge device, the extra payload is removed, and finally the packet is delivered. So no STP is used. The intelligence of ISIS as a routing protocol is utilized. So basically, and the best advantage, I would say, the switch utilization is also very low with using the Fabric core, because if you know that if in a regular traditional way of working, if user server is trying to communicate with server B, there will be gratuitous ARP, it will be a ARP request, all sort of ARP queries will be traversing through the network. But with FabricPath, the only it only learns MAC address selectively. No unnecessary learning. The MAC database table of the switch is very low, and you can go through this slides, go through the content. I have mentioned it. It performs a selective learning. So so the selective learning, what we call, where MAC address table of a switch holds the data where to and fro of the MAC address where the communication is actually happening. So it performs a handshake. It performs a layer 3-way handshake between the source and destination. To only then the database of this switch will be populated with the layer 2 MAC addresses. It's very nice. It's a very pretty protocol. Yeah. So that's the key components. I have mentioned it on the slides. You guys can go through it. And the lab configuration. Configuration, as you can see, it's very, very simple. It's pretty, I don't know, it's so simple. You have to create a VLAN and once you enable this VLAN, you have to just enable these features. You can verify once you have configured these interfaces. You can basically when you run a command show interface brief, you can basically see the status. I've taken these screenshots from the internet because I don't have currently lab with the FabricPath running on them. So I'm just pasting all this information for your references. You can run these commands if you're running this protocol in your environment, or maybe you're preparing for the interview. Yeah, I think you have already went through this. That should be all. I hope the session is useful, and you can find the link of this PPT in the description section of this video. And I want to thank you for watching, and I hope this video was informative. Thank you for your time.